Happy Friday, everyone. Today we're going to continue our discussion about quantum numbers. Yesterday we talked about the principal quantum number, which was basically your energy level, which was the average distance from the nucleus of that electron. Now, just to recap a little bit, quantum numbers, the purpose of a quantum number is to narrow down the location of an electron. So we don't know for sure where an electron is. We only know the probable location. Wait for it. There we go, the probable location. And that's what those quantum numbers are for, to narrow that location down. So yesterday, when we talked about that principal quantum number, we talked about that being the energy level. Now we're going to narrow it down from there. So if we know the average distance, then we can narrow it down one step further using what's called the sub-level quantum number. And the sub-level quantum number is the orbital's shape. And we haven't defined this term orbital yet, but go ahead and write it down. It's the shape of the orbital within the energy level, and the number of sub-levels is equal to the number of the energy level. I think of an electron living in a house called an orbital. So an orbital equals an electron house. It can hold 2 electrons max. So each orbital is where an electron lives, can hold 2 electrons at the most, and they are within an energy level. Now don't try to picture this in your head. Don't try to picture how there's going to be something inside of an energy level, because it doesn't work. Sublevel is a shape, and the number of shapes is equal to the number of the energy level. So let's look at this for a second, try to wrap our brains around it. The first energy level can hold 1 sublevel, so 1 shape, and that shape we're going to call S. Remember, the number of sublevels is equal to the number of energy levels. So the first energy level, this guy right here, he only has 1 shape. The second energy level, this one here, has 2 sublevels. So the first, the S, and then we're going to add to that a P. Now, I'm showing you some of the shapes here on the side of the screen, but we'll talk about those more in a second. The third energy level has 3 sublevels, your S and your P, and then a D. And your fourth energy level has 4. And it turns out that we don't know any more shapes than these 4. So the 5th energy level should have 5, but the only sublevels we know of are S, P, D, and F, so we don't know what that 5th shape is. S, P, D, and F are the only ones we know of. So that's the sub-level quantum number. I think we're going to talk about it a little more here. The energy of the sublevels increases. So like, let's say you're in the 4th energy level here. If the 4th energy level is an S shape, then that would have less energy than an electron within the 4th energy level with a P shape. So this electron's first 2 quantum numbers would be 4 and S. This electrons would be 4 and P. I know S and P aren't numbers, but it's still called the sublevel quantum number. If you're thinking about narrowing down an electron's location, the city is the energy level, the street is like the sublevel. So the orbital shapes are shown here. An S sublevel has a spherical shape. A P orbital, this says dumbbell, I'm going to call it peanut. And a D orbital is a double dumbbell or a double peanut. The reason that I changed that one is because if you think of it that way, then the letter of the orbital starts with the letter of its shape. So this would be a 3-dimensional region in space where the electron is traveling. So its overall path, when it's going around the nucleus, ends up looking like a sphere. So what's the difference between, remember, the second energy level has 2 shapes, S and P. What's the difference between a 1s and a 2s? Their second quantum numbers are the same, but their principal quantum number is different. The 1s would be a spherical, but it would be closer to the nucleus than a 2s. So a 2s would be a sphere like this. What about a 2p versus a 3p? They're the same shape, so there's a 2p, but the 3p would travel farther from the nucleus. Whoop, so far that it's off my page. So this is the path that the electron is traveling in. It could be within, remember, it's the probable location, so it's probably spinning around somewhere in this shape at a certain distance from the nucleus. So here's some more. Here's your S. Here's your P. Here's your D, your double peanut, and your F you can think of as a flower, but it's really complex. It's almost too complex to draw in 2 dimensions. The shapes I want you to know are S is spherical, P is a peanut, D is a double peanut. All right, let's jump into the third orbital quantum number. This is the actual orbital. Remember, an orbital is an electron house with 2 electrons per max, and the number of orbitals per sublevel, remember sublevel is shape, so think about houses, electron houses per sublevel shape, or we call that the street. So like how many electron houses are on that street. The s orbital holds 1 orbital. The p shape holds 3 orbitals. The D shape holds 5 orbitals, and the F shape holds 7 orbitals. Now that's just random. That's just what we know. You're just going to have to trust me on that. That's what it is. S holds 1, P holds 3, D holds 5, F holds 7. And remember, these are like electron houses. 1 electron house. So if we know 1 house holds 2 electrons at the most, we can also figure out how many electrons can be held in each shape. So for the s orbital, you can hold 2 electrons max in the s orbital, 1 times 2. In the p shape, we can hold 6 electrons, 3 orbitals at 2 electrons each. Now they don't have to hold that many. That's just the maximum amount. So D can hold 10, 5 times 2, and F can hold 14, 7 times 2. This is the electron house. So you can see that as the shape gains energy, you can hold more electrons in it. Finally, we have the spin quantum number. And the spin quantum number tells me once I'm in this house, which direction are the electrons spinning. And the only number, or the only symbol we use for the spin quantum number is a positive or a minus, showing which way they spin. Now sometimes if I were to draw an orbital like this, just kind of as a circle that electrons can go in, instead of putting plus and minus, we would say 1 electron is spinning this way and 1 electron is spinning this way. Now remember that for 2 electrons to be legit, they have to have a set of 4 different quantum numbers, so none can be the same. So let's look at this. Let's say that 2 electrons are both in the 4th energy level. Let's say they're both spinning around in the S shape, so they're in a sphere. Let's say because it's the S sphere, there's only 1 electron house, so they're in the same house. But if they're in the same house, they have to be spinning opposite directions, so this part would be different. So we'll say orbital 1, spin clockwise, spin counterclockwise. So all these 3 quantum numbers match, but this last one is different. So the electrons are so close that they're in the same house, they have to be spinning opposite directions. Okay, that's it for 4-3. I know it's a lot, but we're going to practice with it quite a bit. Just try to remember for now which quantum number means what in general. Like the sublevel is the shape. Best of luck. Have a great day, and I will see you on Monday.